The next type of transformation in topic 3 is called a glide reflection. A glide reflection is a composition of a reflection followed by a translation in a direction that's parallel to the line of reflection. That's quite a definition. So ultimately, a glide reflection is a composition of two or more reflections. A glide reflection, just like the other transformations, is again a type of rigid motion, where everything maintains the same length and angle measure. The 4 rigid motions then that we've talked about in this chapter are reflections, translations, rotations, and glide reflections. So glide reflections being that composition, if you recall back in translations, we had that open circle. That's going to represent a glide reflection, and they can be written in either order. All 4 types of transformation preserve size and angle measures. Just a brief review of the 4 types of rigid motions. We have reflection, translation, rotation, and glide reflection. But let's focus more specifically at the notation of that glide reflection on the bottom right. Do you see how we've got this notation right here before the preimage triangle ABC? Well, I have that written down below. It says capital T 4, 0, and then that open circle again, and then capital RM. So what's unique about this type of transformation is we actually do the reflection first. So we'd reflect over line M first, and we can hear that blue jay in the background. And then second is when we would do that transformation or that translation. So we would translate second. And as long as you recognize that you kind of work backwards in the order that it's written, you'll be able to create your glide reflection. Finally, one thing that's going to make a glide reflection different from what our pictures looked like for the other 3 transformations is you're going to have a picture that represents the reflection and then another picture that represents that translation. Ultimately, you'll have 3 images on your coordinate system. To start off our examples, we're going to take a look at how a translation was a composition and how we utilize that to include yet another type of reflection. When we defined translations back in 3.2, we had our preimage shape, but remember we said technically we reflected over 2 lines. So notice how point A right here, if we reflect it over the y-axis, goes all the way over to A prime. So that would technically have been our image. But for a translation, it has to go again over another line. So now it's going over that line M in blue. And now A translates to A double prime. So we went from A to A prime using a reflection and then to A double prime. We're going to have all 3 of these types of letters on our new graphs for glide reflections as well. And then one other thing to note, I'm just going to kind of bubble this in here. This is really all we're going to do with example 1. If you're asked to reflect over the y-axis, we know that that's the vertical axis. That's the same as the equation x equals 0. And that would be that vertical line. That's when x equals 0. And if we're asked to reflect over the x-axis, that's the same thing as y equals 0. There we go. So if it says x-axis, the equation is y equals 0, and you'd go in that direction. More often than not, we're going to see now these types of equations to represent x-axis and y-axis. Example 2. This is a composition of what types of transformations? Not everything has to be a glide reflection. We can do a composition of a variety of types of our transformations. If we go from the shape PQR to PQR prime, notice you're kind of turning the shape to get to those 3 locations. So it looks like it starts with a rotation to go from PQR to PQR prime. But then notice how P prime to P double prime goes straight across, Q prime to Q double prime straight across, and R prime to R double prime straight across. It looks like it's being reflected over a diagonal line of some sort. So this would be a rotation followed by a reflection. Not technically a guide reflection, or a glide reflection based off of that information, but it is a rotation followed by a reflection. Now, sometimes we'll be asked to create the transformation, and then sometimes we're asked to create the rule that makes it happen. Let's try that with example 3. Now we're specifically asked to create a glide reflection rule that maps ABC to ABC double prime. So we're starting with that black triangle at the top, and we're ending with that kind of orangey round or reddish one down here at the bottom. So from ABC to ABC double prime. Well, notice from ABC in black to the ABC prime in blue, do you see how the order of the letters doesn't stay the same? So it looks like we're doing a reflection first. From ABC prime, from ABC to ABC prime. I'll just put a prime by each one of them. We're reflecting, but let's see where. Between A and A prime, right in the middle would be right here. And then C and C prime would be the same. B down to B prime, it's right in that middle as well. So I'm going to draw this dashed line in. And notice it goes through the y-axis at 1. That means from ABC to ABC prime, we're reflecting over the line y equals 1. And that gets us to the blue image. Now, from the blue to that orangey red color, that's a slide. You see how it kind of glides from left to right? We just need to figure out how far. So if I count from B prime to B double prime, we're going to go 1, 2, 3, 4, 5 units to the right. So that would be a translation or a glide. Capital T, we went 5 to the right. But notice it doesn't go up or down at all. So then 0 would be the y value change because it doesn't move up or down. So if this is the order that it happened, how we write it out, remember, is backwards. So if the order went 1, then 2, for our notation, and that's what they're asking us to do, is write out the notation. We actually we write the translation first. So we're going to write capital T, 5, 0. And then that open circle means follows, and then the reflection, remember we said over the line y equals 1, so that's that little sub part right there. And then we put triangle ABC in parentheses. I'm going to run out of space here. I'm going to slide this over a little bit for us here. Oh, no, I'm totally out of space, aren't I? All right, I'm going to put my answer down below. Equals triangle ABC. But our final image, everybody, is that double prime. Oh, that's going to be a lot to remember for that. So again, we found the order in which it happened, but the notation is always written backwards. We're going to start by crossing off the triad example. What I don't like about this one is they actually say that you're ending with a single prime, but for these compositions to work, we need a double prime in there. So I don't really like how that example is set up. But let's try the glide reflection example for example 4. Now example 4 is going to be plenty tricky. It says, what is the glide reflection that maps triangle JKL to JKL double prime? What's interesting about this picture is that it's missing that middle image. It's missing JKL regular prime. All right, so to make this glide reflection happen, let's see if we can get that second image to appear in some way. Now, if we think about where point J is located, currently it's down at the bottom, but its final image is up at the top. So that means we need to flip this triangle upside down in some way. Now I notice it kind of hangs out right along that x-axis, or the x-axis right here. So let's see what happens if we first reflect it over the x-axis. And remember, that's the same thing as saying the reflection over the line y equals 0. So let's see what happens if we do that. Notice point J is 2 units away from that line. So I'm going to go 2 units up to the top, and that would be J prime. L would also move 2 units up above. And K is 1, 2, 3. So I'm going to move 3 to the other side. And that would be K prime. So now I'm just going to get rid of those little loops. I know it's a little bit of extra work. Sorry about that. Just so we can see where our image kind of appears for JKL prime. If I connect J to L, now I'm going to take a look at J to K. There we go. And then L to K. All I did was reflected triangle JKL kind of right onto itself. And now see that the order of the letters is kind of similar. From J, L, and then down to K, look at that reddish kind of orange triangle. JL goes down to K as well. We just have to figure out now what is the translation that gets us there. So now we've got to do that glide from one image to the other. How far are we translating to? Well, we really don't go at an angle like that. Remember, we have to count left or right first and then up or down second. So if I look at my arrow, it looks like I went 5 units to the right and then 2 units up. That would make my translation 5, 2. Notice it's right, so 5 is positive, and it's up, so 2 is also positive. And that looks like what it would take to get the green triangle to that orangey red triangle. Now the notation for our final answer, remember we always write it backwards. So we're actually going to start with the translation. So we would say translation of 5, 2. Then we use that open circle, follows the reflection over the line y equals 0, which we know as the x-axis. And then we start with our pre-image, triangle JKL. Once it's done, your final image is JKL double prime. And there you go. That is your entire notation. For our final example, we're going to take quadrilateral RSTV and create a glide reflection to RSTV double prime. The first thing I'm going to do is just rewrite the 4 ordered pairs for the pre-image and then graph it. So pause the video, plot the ordered pairs for RSTV, connect them, and then list them over on that left-hand side. Then press play and we'll perform the glide reflection. Okay, hopefully your shape looks something like this, RSTV. Now the rule is T50 follows the R over X axis of our pre-image. This is our notation right here. And based on the order in which it's written, the first thing we're going to do is the reflection over the X axis. So up at the top, I'm just going to kind of create a grid. And I'm going to section off my 2 kind of columns for my new ordered pairs. So if we reflect over the x-axis, which is the same as y equals 0 again, the rule to reflect over the x-axis is we simply just change the coordinate for y. We just make it the opposite sign. And it's going to be hard for me to, there we go, got that in there. So r prime is going to go to -3, -2. S prime is going to go to 0, -5. We're just changing all the signs. Ooh, but watch T. T prime is going to go 4, but then up to 4. Oh boy, so that one's going to go on the other side. And then V prime is going to go 0, but then up to 2. All right, again, pause the video and plot these coordinates in green. This is going to give us the reflection over the x-axis. All right, everybody, take a look at that reflection over the x-axis. So here's what's unique about the final part. Our translation is going to be 5, 0, which really just means we're shifting everything 5 units to the right. So that's going to be our last part, and that's going to give us RSTV double prime. But what we have to recognize is that we're changing these values for x and y, not the original. So to get r double prime, I'm going to add 5 to the x. -3 plus 5 is 2. And then -2 plus 0 is -2. To get s double prime, 0 plus 5 is 5. And then 0 plus -5 stays -5. Notice all your y coordinates aren't going to change, just the x coordinates. T was at 4, or T prime was at 4. T double prime is going to go all the way over to 9. And then last but not least, V prime was at 0, 2. It's now going to go all the way over to 5, 2. All right, one last round. Pause your video one last time and plot those ordered pairs. And let's see what it looks like when we're done. And all I can say is, wow, I colored mine in, and especially if you're not using different colors in your notes, which is absolutely okay, I highly recommend you color in that double prime final and result image, just so you can tell kind of what happened with the whole transformation. We started with the quadrilateral RSTV. We did a reflection followed by a translation to create the glide reflection image. And that's lesson 3.4. We'll do that final example in class tomorrow.